Good morning. So in this recorded lecture, we will discuss the probability of an event. So perhaps it was humankind's unquenchable thirst for gambling, okay, that led to the early development of probability theory. In order to increase their winnings, gamblers call upon mathematicians to provide optimum strategies for various games of chance. Some of these mathematicians included Pascal, Leibniz, Fermat, and James Bernoulli. And as a result of this development of probability theory, statistical inference, with all its predictions and generalizations, has branched out far beyond games of chance to encompass many other fields associated with chance occurrences, such as politics, business, weather forecasting, and scientific research. For these predictions and generalizations to be reasonably accurate, an understanding of basic probability theory is essential. So essentially, the theory of probability actually originated um, from the works of those mathematicians hired by gamblers in order for them to increase their winnings in a game of chance. So, but the tools developed and the tools and theories developed for this um, purpose, for gambling's purpose, actually had extended to other fields. And that is why um, one of the many useful branch of mathematics today is the probability theory. Now, in some of our everyday conversations, we most likely be talking about probability, okay, without actually quantifying it. For example, we may say that John will probably win the tennis match, okay? Or I have a 50-50%, I have a 50-50 chance of getting an even number when a die is tossed, okay? Or the university is not likely to win the football game tonight. Or most of our graduating class will likely be married within 3 years. So these statements, except possibly for the second one, okay? Um, these statements like probably, not likely, will likely are qualitative measures of probability. These are qualitative, which means they state probability in one way or another, but they don't really quantify, or they don't really put it into numbers. Okay. Unlike this one, the second statement, which states that there is a 50-50 chance. So meaning 50% probable that I will get an even number, and 50% of not getting an even number. Okay. Every time, uh, and this happens every time a die is tossed, which is or which you can imagine, which you can easily imagine, because since there are only 6 numbers in a die, and we have already studied sample space. So the sample space of a die would be 1, 2, 3, 4, 5, 6. Okay, and the event, okay, that represents the event that that the event that you get an even number, okay, from this sample space is 2, 4, and 6, and the event that returns an odd number when you toss a die is when the outcome is 1, 3, and 5. Okay, so um, we may not understand how to quantify probabilities as of now, but this number, 50% of getting probability of getting an even number, and 50% of not getting an even number, is true in this case. Okay, and later on we will be able to verify that kapag marunong na tayo mag-quantify ng probabilities. Okay, but again, these statements that we have just read, okay, actually states probability in one way or another. Okay. Now, in each case, okay, in each case, we're expressing an outcome. Okay, we're expressing an outcome which we are not certain. Okay, the outcome that we are trying to, we are trying to state here is an outcome that is not certain. Okay, but owing to past information. Okay, past information, meaning historical data. Okay, you may be, you may be basing it from um, a collection of data collected over time, okay, or from an understanding of the structure of the experiment, okay, we have some degree of confidence in the validity of the statement, okay. So the probability, when we, when we quantify our probability, or when we state probabilities, um, it is possible that, that these quantities actually come from two types of information. Okay? So, yung una nga is past information or historical data. Okay? If we look at the data from the past of an event, okay, then we can, have or we can state with a certain degree of confidence what would be the probability or what would be the chance, okay, that a certain event will happen again. Okay. And number two, another source of your probability, or another source of the basis of quantifying your statement of probability is the structure of the experiment. Okay. And one example of which is this one. Okay. So that 50% chance, okay, or that probability of getting an even number, okay, is 50%. And the probability of not getting an even number is 50%. We're talking about this probability is actually referred to, this probability is referred to the tossing of a die. Now, since we are familiar with the experiment, the tossing of a die, and that we have already know what would be the sample space, okay, what would be the sample space of tossing a die, and the what would be the subset, okay, of the sample space that gives us an even outcome, and what would be the subspace, subset of this sample space that would give us an odd outcome, then we can compute for these probabilities. Okay, so if you know the structure of the experiment, you will be able to have a basis of the statement for your probability. So from this point on, when we talk about probabilities, we will consider only those experiments, okay, for which the sample space contains finite number of elements. Okay, so that since we are studying probability in in the entry level, okay, we're just starting to study probability. We will understand the probability, the concept of probability uh, from looking into examples of experiments that are or that have a finite number of elements in its sample space. The likelihood of the occurrence of an event from such a statistical experiment is evaluated by means of a set of real numbers, okay, called weights or probabilities, ranging from 0 to 1. Okay. The keywords here are likelihood of the occurrence of an event. Okay. And that likelihood is called weights or probabilities. But we use probabilities more often than not. Okay. And the probability as a quantity, okay, would range, okay, from 0 to 1. And this probability is a continuum, okay? This is a continuum of numbers. This is a continuum of numbers between 0 and 1. Included ang 0 and 1 when you talk about probabilities. Okay? So when you say continuum of numbers, your probability can assume any number between 0 and 1. That's it. Kahit ano pa yan, kahit the probability is 0.12457993. Okay? It can take on any degree and any precision of numbers as long as that number is between 0 and 1. So yun yung continuum of numbers. And again, in that continuum of number, okay, 0, the number 0 and the number 1 are included. So which means it's possible that your probability is 0, okay, or your probability is 1. So later I will explain what is the meaning of stating that the probability is 0 or the probability is 1. Okay. Now, to every point in the sample space, okay, we assign a probability, okay, such that the sum of all the probabilities is 1. Okay. So, say for example, again, going back to the tossing of the die experiment, since the sample space would contain 6 numbers, 1, 2, 3, 4, 5, 6, okay, we will assign a certain probability for each of these elements of the sample space. So we will have the probability when your outcome is 1, okay, the probability when your outcome is 2, the probability when your outcome is 3, and so on, until you have the probability of the outcome of tossing in a die is 6. Okay. Now the thing is that if you add all of these probabilities, okay, the sum of the probabilities of tossing a die, okay, should equal 1. Okay, so the sum of all these probabilities should equal 1. So now, if you have a reason to believe, okay, if you have a reason to believe that a certain sample point is quite likely to occur, okay, when the experiment is conducted, the probability assigned should be close to 1. Okay? Ibig sabihin, pagka sigurado tayo na yung event, okay, or yung outcome is or the element of the sample space is likely to occur, okay, its probability may be much closer to 1 than to 0. Again, ang range ng probabilities natin is from 0 to 1. Okay? So, kung ito yung if this is the continuum of numbers for your probability, so this is 0 and this is 1. Okay? If your event is likely to occur, or if the outcome, or if the element of the sample space is likely to occur, okay, we can assign a probability that is much closer to 1 than to 0. Okay? In the same manner, okay, a probability closer to 0 is assigned to a sample point. So, probability closer to 0, okay, is assigned to a sample point that is not likely to occur. So, if the event, or if the sample space, if the element of the sample space is not likely to occur, okay, so not likely to occur, then we can assign its probability to be much closer to 0 than to 1. Okay? So, um, any points or anything, any outcome, okay, any outcome that has no chance of occurring, okay, is assigned a probability of 0. So, no chance. Okay? So, kapag ang outcome ninyo um, does not have any chance of occurring, okay, then the probability assigned to it is 0. Exactly 0. So, mangyayari yan kapag yung outcome ninyo ay wala dun sa sample space. For example, if you are to toss a die and you know that this is the sample space, okay, of tossing a die, then the probability of getting a 7 is 0. Kasi wala naman yung 7 dyan eh. Okay? So therefore, there's no chance that you would get a 7 when you toss a die. Okay? So, now, if we are very certain, okay, we are very certain that that an outcome, okay, would occur. Yung sigurado talaga tayo na mangyayari siya. And that's because that outcome is deterministic. Okay? Which means yung outcome that you are trying to state is determinable. Okay, it's possible that you can determine it by a method or another. Okay, so that's so that we are certain that that outcome would actually occur. We will assign that a probability of 1. Okay, so certain of occurrence of outcome. Okay, so that's how that is how we should interpret this probability continuum. Okay, so again, if there is no chance for your outcome to happen because it does not belong, or that outcome does not belong to the sample space for that particular experiment, then we will assign that a probability of 0. If the probability of the element of the sample space occurring is less likely to occur or not likely to occur, then the probability may be much closer to 0, okay, than to 1. And if the probability, okay, if the probability of or if the sample space, or if the element in the sample space is likely to occur, okay, then we can assign it a probability that is closer to 1 than to 0. Okay. The thing is that the sum of all those probabilities of each of the elements of your sample space occurring must equal to 1. Okay? So, there. So, ito yung sinasabi natin kanina. Points outside the sample space, okay, is assigned a probability of 0. So, if we're going to evaluate the probability of an event that is not found on the sample space of the experiment, then the probability of that occurring will be considered to be 0. Okay? So, to find the probability of an event A, again, as we recall that an event, okay, we recall that an event is a subset of the sample space. Okay? So, to find the probability of an event A, we sum all the probabilities assigned to the sample points in A. So, before I proceed with this one, let me just add, okay, let me just add here in the continuum a scenario where we can consider that the elements of the sample space have equal chances of occurring. Okay? So, meron tayong mga experiments wherein the elements of the sample space have equal chances of occurring. Okay, ang example natin dito is ang example nating experiment na merong ganitong case is one, tossing an unbiased unbiased coin. Okay. Number two, tossing an unbiased die. Okay. And I would like to highlight the word unbiased in both examples. Okay? Because when you consider that when you consider a coin or a die is unbiased, okay, it means that all the possible outcomes, okay, or all the members or all the elements of its sample space would have an equal chance, okay, of occurring. Okay. So, kapag unbiased yun, kasi minsan kasi, for example, yung coin natin can be modified in such a way that it would show more of heads than more of tails. Okay? So, biased coin yung tawag doon. O kaya, we can modify your dice or your die in order for it to produce one or more numbers more often than the other numbers. Okay? So, possible yun. Okay? So, pagka ganun, meron tayong tinatawag na biased na die. Okay? But if we consider our coin or die to be unbiased, okay? Then we can say that the outcomes or the elements of the sample space in each of the experiments have equal chances of occurring. Okay, so paano mangyayari ngayon yun? Halimbawa sa tossing of a coin. Okay, when we toss an unbiased coin, ano ba ang sample space nun? Okay, we recall that when you toss a coin, okay, your sample space would contain either a head or a tail. Okay? Re-recall natin yan. Okay. So ngayon, again, we will assign a probability. For this one, we will assign a probability for the coin to give up head as an outcome. Okay? Or, and a probability of the coin giving tail as an outcome. Pero tandaan natin na kapag inad natin to, dapat ang maging sum ng mga probabilities na yan, okay? Ang maging sum ng probabilities na yan should be equal to 1. Okay? So, for this to be equally para maging equal sila, okay? So that these two are equal. If we assign x to the probability of the head occurring, okay? We will also need to assign x, okay? For the tail, x as the probability of the tail occurring. So therefore, again, the sum of these two, x plus x equals 1, or 2x equals 1, okay? And therefore, x is 0.5. Okay, so therefore, in an unbiased coin, we assign the probability of 0.5 for the element head. Okay? And also 0.5 kasi nga equal sila for the element tail. Okay? So, 'yun. Doon natin makita na equally probable na lalabas yung head at saka yung tail. Okay? Sa case naman ng die, okay, since again, the sample space is 1, 2, 3, 4, 5, 6. Okay? So again, we assign probabilities for each of these elements. So yung probability na 1 yung lalabas, at saka yung probability na 2 yung lalabas, yung probability na 3 yung lalabas, probability na 4 yung lalabas, probability na 5 yung lalabas, and probability na 6 yung lalabas. Okay? Now, we take note that if we add all of this, okay, the probabilities should sum up to 1. Okay? And if these are equal, okay, if these are equal probability event or equal probability experiment, we will assign equal values for each of these probabilities. So let's have it to be x. So x for the probability of 1 to occur, okay, x for the probability of 2 to occur, and so on. Okay, and again, if we add these x's, okay, if we add x plus x plus x plus x plus x plus x, anim yan, okay, equals 1, then we will have 6x equals 1. So therefore, x equals 1, 6. At ito yung probability na i-assign natin for each of these probabilities. Okay? O for each of these elements of the sample space. So 1/6 ang probability that probability of 1 would occur. That 1, but we will get a 1 when we toss a die. 1/6 din kapag 2 na makukuha natin. 1/6 din pag 3, 1/6 din pag 4, and pag 5, and same thing pag 6. So we take note that if we add all of this, again, this would sum up to 1. So dyan natin makukuha yung 1/6 na probability nito. Okay? So there. Now, so again, babalikan ko to. To find the probability of an event A, okay, we sum, okay, the probabilities, okay, assigned to the sample points in A. Okay? So this sum is called the probability of A and is denoted by P of A. So this at this point, we're talking about the probability of an event naman. Okay, so we're talking about the probability, okay, probability of an event. Dito kasi medyo pinag-usapan natin dito, okay, is probability of an outcome. Okay? So basically, ang ina-assign nating probability ay para dun sa bawat isang element nung natin. Sample space. Okay? So, ganun din dito. So, we can consider this to be the probability of an outcome. Kasi isang outcome lang yung pinag-uusapan natin. Okay? Although later on, kapag medyo pinalalaki na natin yung konsepto ng probability, or when we continue to discuss probability and we're going at it at a larger and a larger scale, mag-blur na yung lines between probability of an event at probability of an outcome. Pero make sure na naiintindihan niyo yung difference ng dalawa. Okay? So, the probability of an event A is the sum of the weights of all sample points in A. Okay? So therefore, since the probability of A is still between 0 and 1, okay, the probability of the events or of elements outside element A, okay, is still 0. And the probability of your of all the elements of your sample space is equal to 1. Okay? So, yung tatlong definitions na yan would still hold true. Okay? So, again, yung sinasabi natin dito sa probability of S na to equals 1. Ito yun. Kapag ka-inad natin lahat ng probabilities ng events inside the sample space, kailangan maging 1 yan. Okay? And again, kapag humanap tayo ng probability ng anything na wala dyan, okay? So, say not S. The probability of an event that is not found in the sample space S, that would be 0. So, sinusulat natin din to as the probability of the null set. Okay? So, that's equal to 0. But, talking about the probability of A. Okay? Talking about the probability of A. Okay? Again, A is an event. And again, when you say event, it means it is a subset of the sample space. Okay? So, katulad nung babalik natin yung yung example kanina tungkol sa 50 chance, okay, of getting an even number. Okay, let us say that event A, okay, is yung subset nito where the outcome is an even number. So, yun na nga yung 2, 4, and 6. Okay? Now, we take note that yung probability of 2 occurring, okay, the probability of 2 occurring is assigned to be 1/6 based dito sa original na sample space natin. The probability of 4, okay, occurring is 1/6 din. Okay? And the probability of 6 occurring is 1/6 din. Okay? Now, if we add all of this, okay, that should give us the probability of the event A, which gives us that's 1/6 plus 1/6 plus 1/6 is 3/6 or 1/2. Yun nga yung 50% o yung 50-50. Okay? 1/2, 0.5, 50%, 50, they mean the same thing pag probability yung pinag-usapan natin. Okay? So, kaya yung probability of getting an even okay, number is 50%. Okay? So, yun, that's the probability of an event. Okay. Now, we have additional definition here. Furthermore, if A1, A2, A3, these events, okay, is a sequence of mutually exclusive events. Okay? Ano ulit yung mutually exclusive events? So, mutually exclusive events, we defined it sa previous lesson as this one. Okay? So, mutually exclusive event to. Yun. Okay? So, two events A and B are mutually exclusive or disjoint if the intersection of events A and B is a null set. Ibig sabihin, there is no common element between A and B. Okay? Again, A and B are both subsets of S. Okay? Pero kapag ka si event A tsaka si event B ay walang common element, this one is again the intersection operation. Okay, it finds common elements between sets. Okay? So, kapag ka wala siya nakitang common events, okay, dun sa dalawang events na yun, wala siya nakitang common elements dun sa dalawang events na titignan niya, A and B. So, yun na nga, magiging null set siya. Okay? Then we can treat events A and B as mutually exclusive events. Okay? Now, if the events A1, A2, A3, and so on is a sequence of mutually exclusive events, okay, then the probability of the union of all these events, okay, is the sum of their probabilities. Okay? Madali namang makita yan. Okay? Madali namang makita yan. For example, pwede nating tingnan yan dun sa case ng tossing of a die again. Okay? So, we can have an event A as the probability, the event A as the elements that are even in the subset, in the sample space S. Then we can have, for example, B, an event in which the outcome of tossing a die gives off an odd number. So, from the sample space, yung mga outcomes na yon are 1, 3, and 5. So, it is easy to see na yung na walang common na elements between A and B. Wala kayong makitang common dyan. Okay? Pero, pag hinanap nyo yung probability of A or U, yung union ng A at saka ng B, okay, occurring, okay, that should be simply as the probability of event A occurring plus the probability of event B occurring. So, alam na natin na yung probability of A occurring is 0.5. Mako-compute nyo rin ito, yung probability of B to be also 0.5. Okay? So, therefore, pag kinuha nyo yung yung probability ng union nila, okay? And take note yung union ng A at saka ng B is actually the subset S. I mean the sample space S. Okay? So, yun. Pag inad natin ito, this should be 0.5.